Hey everybody, welcome to Houdini Hangout. It is the beginning of September here, and we're doing another MOPS Monday. Hope you're having a great day. Hope you're having a great Monday. Or maybe it's Tuesday where you are. I don't know. Time zones are a thing and hard to figure out sometimes. But yeah, hope you're having a great day. And so we're going to be talking again about MOPS, about dynamics today. And we'll be looking at some specific uses of the MOPS Plus tools, which obviously are are kind of the paid version of MOPS, but it gives you access to be able to use those tools in the tool set in the dynamics context, which can be really, really powerful and makes for a bit less painful setup of animated, attributes and things like that. You can use a little bit more along the lines of, just just adding attributes using like falloffs and things like that. And it's just way easier to kind of work with your these attributes in this way, a little bit more visually, a little bit more artist friendly, and kind of allows you to play around a little bit more and get some good results. And obviously through the process of doing these videos, I get to play around and kind of figure out a bunch of stuff as well. So that's pretty fun, and I've been enjoying that. I think the tools are really great, and I highly recommend at least downloading the free one just to play around with them. And maybe through these streams you'll find a reason to get the paid ones. I don't know, but they're great, really helpful. And, I think they give you a lot of flexibility and control that, sometimes people feel like, oh, hey, KG, how's it going, man? Welcome to the stream. Sometimes people feel like, Houdini is so difficult to be able to get in and learn. And there are some difficulties. There's some things you have to kind of retrain about the way you're thinking. But the nice thing about these tools is that obviously they're going to allow you to, sort of do things that feel maybe familiar coming from other software packages and things like that. So they're a great set of tools. Let me just go over here and bring up MOPS just so we can all, just in case anybody isn't familiar with, what it is we're talking about. Here's the website for MOPS, motionoperators.com. If you want to get them, you can go right to GitHub here and download. There's instructions on how to load the package and be able to kind of work with the tools from there. So it should be a pretty familiar thing if you've ever installed anything at all, like QLib or any other library of any other package basically that you may have installed into Houdini. You should feel pretty comfortable with installing those. So also another thing just to always kind of mention here is that these tools, while they are really kind of have this built-in kind of mechanism and thought process kind of that goes behind them, they are built on Houdini. Like there isn't anything really happening here that you couldn't do yourself. But that's the beauty of it, is that you don't have to sit down and build these tools yourself. Somebody else has done it for you and gives you the access to that. So, it is all really default, Houdini, but just everything packaged up in these nice HDAs, Houdini digital assets. That's really what it is you're paying for, is for the tool making time that, Henry and the others that have spent their time on motion operators have done. So, that is kind of where we're at here. So today we're going to be talking about dynamics. We're going to be talking about how to, use different falloffs and things like that to influence your, your simulations and things like that. We'll probably start with a really simple grain simulation first, which actually gave me the most trouble because there's one stupid checkbox that you need to uncheck that I just like a dummy forgot. So I was like, oh no, Henry, I think something's wrong here. And turned out the thing that was wrong was between the chair and the keyboard and mouse. So anyways, there's one little gotcha there that hopefully will help, that you don't have to struggle through. And yeah, so the last thing I want to say, as I always do before any stream, and probably multiple times, is if you have any questions, if you have any thoughts, if you have anything at all that you think maybe we could do better or more logical ways of going about things, please let me know in the chat. Always like to hear from everybody. This isn't just me talking to you and telling you, hey, Lignazio, welcome to the stream. This isn't just, me talking at you, but hopefully we can have a bit of a conversation, a little bit of back and forth. You can bring your questions and thoughts and ideas and things like that, and we can kind of talk and, make some things on the fly a little bit, and kind of be able to teach you, and hopefully even I can learn a little something. It's always nice for me to be able to learn a little something. Hey, Moses, welcome to the stream. But yeah, so please feel free, drop comments in the chat. There are no stupid questions. There are no stupid, things that you might be struggling with. If you're struggling with it, most likely someone else is as well. So please feel free to, drop those ideas in the chat. So with that being said, I'm going to start this up, and let's jump over to some Houdini. So the first thing, like I said, that I think that we'll set up is a grain simulation, because I think this will give us a really good kind of, starting point to be able to talk about what's going on with our attributes and things like that. So we can kind of see it on a more basic, just simply point level, right? So let's do that. So let's do a geometry here, and I'm just going to say sim grain. We'll do that. And jump inside. Let's do just a box here to start with. I'm going to make like a flat container of grains. So let's do this. We'll do maybe, let's see how that looks. So we'll do 0.1 like that. And then let's do a points from volume. Let's do that. And this will make, obviously, like it says, points from the volume that we've kind of created here. Now our volume is obviously this box here, so we can kind of play around with this and see, how we want to set this up. And maybe that's good like that. Cool. Maybe we do like the tetrahedral kind of thing here, whatever. Actually, now that I'm thinking of it, we can just use a vellum configure grains, because I'm actually going to do this later. And I was getting ahead of myself. So let's actually do this instead. Let's do vellum configure grains. My brain's a little out there today. So, all right. So this will create points from volume. It's actually doing the same thing internally, but this is going to set up our grain attributes as well. Whoops, I meant 0.5, 0. Just type properly. Let's see. Okay, there we go. 0.25, that looks good. And so, okay, so we've got kind of a layer of grains here. However, let's do a couple things first. Let's do a match size here, and we'll bring this up. We'll just set this to minimum, and that'll basically bring it up to the ground plane here. So now we've got our grain like this. We've got our box here. Now, this is what it's trying to kind of, if we were scaling it, it would try to scale to that, but we're not scaling it with the match size here. So, okay, so we're going to do that. Let's also create a collider for this, because while we will have like a ground plane, let's make like a little container for this. So what I'm going to do is I'm going to do a blast node here. I'm just going to take the top off of this. I'm just going to hit the select, grab the top here, and hit enter in the viewport. So now we've got kind of like a tray, more or less, and I'm going to do a poly extrude, and we can just give a little distance here. I don't know, maybe something like that, 0.1. Make sure we output the back, and that makes sure that stays as is. In this case, the ground plane is actually, yeah, I guess what we could do instead is, we could instead do this. We could match size on this here, and I'll show you a cool little trick. So this will make sure that this sits the ground plane. However, now this is lower. So what we can do is, let's see, attribute copy over here from this. And hey, Matt, welcome to the stream. So what I'm going to do is we're going to do this transform here. So now we have a transform attribute. I'm going to come over here and copy xform. And that'll put it over there. And then what we can do is, I think there is a transform by attribute. There we go. And this will bring it up as well. So this just basically copies it over, puts it in that spot. So now this is up in the air and it matches right in the same spot as this. So just as a little example of, or just a little explanation of what I did there. So we have a match size here. This is just moving this up so it sits on the ground plane. And we're just saving this transform attribute here in the detail. So here is our transformation right there. There's our transform matrix or whatever. And so what I'm doing is just copying that over to this stream because obviously this is kind of sitting at origin. And then I'm just doing a transform by attribute and I'm just going to say match container xform. There we go. This will be copy xform. I'm going to try to make these as descriptive as I can because if you're able to download it, it's nice to be able to kind of follow along here. So we'll say place on ground. I think these are explicit enough. I think we've got blast and a poly extrude. I think we know what's going on there. Let's copy xform. Cool. Okay, so we've got our grain here, and I'm going to actually wire this into our collisions input here. Now, it's not going to do anything here, but these just kind of go down, and it makes maybe the network a little neater. So let's do a vellum solver. We'll drop this down. And okay, cool. So we've got these particles here in this container. Let's add a ground position in just because these will probably spill out at some point. And if we just run this simulation, we'll see that they kind of settle down, but they got a little jitter going on here, a little bounciness, which is interesting. So I'm just going to add in another substep because we're going to need it anyways. Let's see what happens here. There we go. Cool. Looking good. All right, cool. So this is all working out and is doing some stuff. So that's cool. So if you remember from the last time we were talking about MOPs, you know, there's obviously a few different ways that we could go about doing this, right? We can actually make these attributes at our geometry level here, or we could come inside here and now we're in our dynamics context and we can create those, you know, those MOPs nodes and work with things here. So in this case, when we're talking about anything in dynamics, these are all the MOPs plus operators, basically. So there's definitely a more limited number of them that work in here. You know, mainly just because this is, you know, we're talking about a dynamics context. We're doing things frame by frame. We're creating attributes and kind of solving them and iterating on them and adding them together and stuff like that. So there's a little bit more, you know, limitation on maybe how some of these things can work. So if you know of a MOPS node that exists in the standard geometry context, just know that it might not always be in the dynamics context. So there can be a little bit of trickiness there. Now, the other thing to note as well is that if we did something like, let's do a MOPS noise fall off. Let's just do that. So we're going to do this on this first stream right here, a little noise fall off. We'll visualize this and let's preview this fall off so we can see it here. And I'm also going to clamp it, make sure it just stays between 0 and 1. So here we can kind of mess with the frequency a little bit. We could mess with the amplitude. So we've got some hotter spots here and stuff like that. And if we do time varying here, right? So now we've got this time varying attribute. I'm just going to make sure my time is on. Cool. All right. Looking good. We've got our time varying on. However, if we go inside of here and play this back, you're going to notice that this actually isn't time varying at all. It's just staying kind of static. So we need a way to be able to pull these attributes in, right? We need a way to be able to kind of get attributes inside of the dynamics context to kind of update the same way they are updating in time, because once you bring something and import into dynamics, it has kind of its own object here now that it's stored on. And if you remember, we've talked about this a little bit. Like, for example, here's the geometry for this, right? Here's the geometry kind of container. You can think of these as like containers that hold data. So we've got the vellum object that holds all these other smaller containers with them. Hey, Epoxy, welcome. Oh, you're welcome for starting early. Glad to have you. These are all kind of containers of data that get stored inside of DOPs. So when you're dealing with these things, it just kind of imports them once. So here we're seeing the color that's being imported, but it's only being imported on the first frame. So we're not actually updating that at all. So like I said, we need a way to bring those in. So what we can do is we can bring up the MOPs fetch attribute. So this is a way that we can actually fetch attributes, right? So here, let's just do something really simple, right? We know we're coloring these things. So instead of worrying about our fall off right now, and we'll leave that for now, let's just do something we're going to visually be able to see. Let's do CD and CD here, right? And this is 3 floats. So destination is going to be 3. So let's see what happens here. And there we go. Now we've got updating color in here. Now this isn't inherently doing anything, right? It's not giving us anything at this point, right? So we have color, that's great, but it's just kind of updating and solving, and it's not really doing a whole lot of anything at this point. What we really should probably do is have an attribute that allows us to actually do something, right? So let's do that. So let's take this attribute here and let's apply. Let's bring the fall off in first of all. So let's bring this back here. We've got our MOPs fall off, and what I'm going to do is I'm just going to make sure that we're kind of explicitly saying where these are coming from, just so we can kind of keep track of them, right? So this is SOPs, right? So there we go. And we'll come back inside of here and we'll just say MOPs fall off, SOPs. And again, we'll just destination. So here we have a source attribute and a destination attribute, right? And this destination geometry is where this is getting copied to. The source is the first context geometry. So that just means the first geometry that's coming in here. Now, technically with this SOP version of the vellum solver, there's technically a couple of networks that we're not seeing here that we've dove into. So just know that this is actually the first input into the DOP network. So in this case, luckily that is fine. But just know that there's other things that you could do here. You could also, specifically, state a SOP that you could go to. So you could just make a null or something and have it point right to that, which we will do a little bit later, but we'll just leave that on first context geometry for right now. So in this case now, we're going to bring this in. We're not going to see the color update, but if let me type in the attributes MOPs, we'll just highlight this, and there we go. So now we have a MOPs fall off SOPs, and it's changing. Our fall off is changing. However, we actually still have this at 3 values because it was a float or a vector. So let's change this down to a float. And yep. So when you see that cache turn orange, that just basically means something recooked upstream, and you need to kind of go back and hey, Paulo and Zach, welcome. So we've got our MOPs attributes coming in here, right? And so that's working for us, right? So that's good. And now we can do some stuff here, right? So let's do maybe MOPs, maybe like a transform modifier here. Let's see. Believe this is what I did before. Let me just double check. Oh, actually, here's what I did. Sorry, just remembering what exactly I had done here. All right, so let's keep this actually on CD. That'll be helpful. And let's go down here and change this. Instead of a transform modifier, let's just fetch and remap this. So let's do this. Mops falloffs stops, and then we'll change this to some P scale. Okay, cool. So we've got these two nodes in here. Let me actually zoom in on these. Sorry, I'm like kind of far away there. Okay, so we've got, this is going to be import CD, and this is going to be convert falloff to P scale. Okay, so I'm going to do a remap here, and our range coming in is going to be 0 to 1. Our out range, let's set this to be something appropriate for us here. So let's look at our P scale that we have, and we can see that this is currently at 0.0125. So let's do that as our 125, something like that. And let's just say 0.025 for our high end. We can always mess with this or whatever. But so now we should start to see the P scale changing. And the other thing we need to do here is we need to do this. Yes. And this is where I ran into trouble last time, and I totally forgot about it. So let's go in here and let's go to the advanced tab, to grains, and uncheck assume uniform radius. Yeah, it can be. Yeah, Lignazio. Yeah, it definitely can be, because we're going to get to that in a second, and I'll show you some different ways that you can set this up. There's a few different ways that you can kind of go about doing this. So this is, yeah, you definitely can do a multiplier exactly instead of an absolute value. So this should work now, I think. Yep, there we go. Now we have them exploding and doing all sorts of crazy things. So that's a little nuts. So let's tweak this a little bit here. So let's go back to our fall off and just adjust this a little bit. Let's remap it. We'll fit it. And let's just take this and go to like 0.9. So we've got just kind of these little hot spots that are actually going to be adjusting here. So just if we watch this real quick, we'll see that these are just little hot spots that kind of fade in and out here. I'm also going to slow this down a little. Nope, that speed it up. Yeah, something like that. Cool. All right, so let's go back inside of here and let's see what happens here. So now we've got some spheres that are blowing up, going back down, right? And like Lignazio was saying, these are going to be, these are going to be kind of explicit scaling, right? So this is if you wanted to have something where each point had a specific scale that you wanted it always to kind of match up to, right? So that is sort of the the kind of the most hard-coded way of doing this, right? This is basically just saying we want this to specifically be this size, and that's it. So I'm actually going to bring the size of this down maybe just a little bit. So let's do 0.2 so it doesn't explode maybe quite as much. There we go. Get a little explosion. But so now you can see here, one thing that that's happening here, right, is that these are growing and bulging and doing some weird stuff based on the fact that they are matching up their attributes. So let's do something to just make sure that we're explicitly telling it what attributes we want it to map to, right? So you don't have to do this. It kind of falls back onto the point number if it doesn't have anything to match to. But let's just do it a little bit more specifically. So let's put an enumerate down. This is a nice little node that allows you to make some sort of index for your stuff. So I'm just going to call this ID because that's what they're usually looking for in the MOPs tools. So this is going to make a point ID. We can see here now each point is an ID. Just this way, if you had changing point numbers and stuff like that, your IDs will be able to you'll at least have some IDs, right, that you can work with. I think if you're sourcing into your vellum grains, I want to say that it actually would add an ID to it, maybe. Anyways, right now we have a static point count, but we're just going to explicitly make sure that we're matching it based on ID. So now we can just say match by ID here. We can match by ID as well there. Yeah, so if you're spawning new particles, the problem would be that your your enumerate would only basically would only take into account these points that are here, right? So if you wanted to enumerate and add new IDs to it, actually the way that it does that in, you would probably have to do something really specific in the DOPS context. I don't actually know if there's a MOPS node for that now that I think of it. Let's see here. Let's see. Tools. No. So I think, is there just a way? No. So basically what you would do is need to know kind of what the starting ID is and then add IDs into those points, basically. Pops does this. I'm not totally sure how Vellum deals with that. And maybe we can play with that later if there's a little bit of time. But yeah, so it's definitely a little weird for that. Have to think about it a little bit. But anyways, I think that would be, would be part of it. And you don't have to use this method either. This is just explicitly kind of bringing that attribute in right from SOPs. We'll talk about a couple different ways you can do this as well in DOPS itself. So you don't even have to leave the dynamics context. You can just work in here. So we've got this sort of working where we've got these points and these things happening here. Oh, what's going on? Why did that color go away? Yeah, exactly. You could do a wrangle node in the Vellum solver, 100%. Yep. I'm trying to keep this like these talks as like little bit of like VEX and programming as possible, just so that people that are maybe new to Houdini or new to doing simulations and things like that don't have to deal with that. But 100% you could wrangle that and that would be no problem at all. So yes, Moses, you're 100% correct. Why is that color not? Oh, that's why, because I turned that off. So there we go. Okay. So now the color will stay and we'll see that actually update. There we go. I was like, why wasn't that updating? So there we go. So this is coming in from SOPs, right? So this is all coming in from SOPs and we're converting that over. So let's look at what that might be like if we dealt with it in the dynamics context instead of from SOPs. So let's turn this off here, right? And let's add in a MOPS noise fall off. So we can do the same noise in here, right? So I can take that same exact noise and we can even match this up and it'll be basically the exact same. So 2.2 and 3 is what we're dealing with there. 2.2, this is 3, this was 0.5. Time varying, cool. I think that's the same. Let's see here. Yep, cool. All right, so if I come in here and I'm also going to unvisualize this just so that we're not seeing that come in. And I'm also going to not preview that so that we can preview this and actually see it. So let's preview this. And I think if we go forward one, yep, we're going to see it. Cool. The reason for that is if you haven't like messed around with dynamics much, the reason that or haven't gotten like in this deep, the reason is that on the first frame, it usually doesn't calculate for dynamics context. That way, any live update that you do in Houdini doesn't have to run through a simulation process to be able to display to you. So the first frame is usually not a simulation frame. So just that's the reason why we're not seeing that color, because nothing is calculated yet in this network. So let's enable the remap here. Let's do kind of the same thing, 0.9. So now we should have a very similar looking noise. I mean, it's probably slightly different, but anyways, it's basically the same. So we've got this noise field. So now we need something that's going to be able to, explicitly kind of, that sets this. So we can take actually the same one here. We can just make a duplicate of it. We'll turn this one on, and instead of MOPS fall off SOPs, let's go here and say, we'll just say SOPs fall off to P scale. And then this will be DOPS fall off to P scale. So this will do DOPS. And so we can kind of leave these wired in. It doesn't really matter. But so now we have our noise fall off. We have our fall off to P scale. So this is still going to be explicitly setting it, but we're doing this all from within the dynamics context. So this should be exactly the same. Now the difference here is that to be able to fetch this attribute, let's just play this and see what happens. And nothing happens. And so let's change one thing here and say myself. And there we go. So the reason that wasn't working was because we were trying to solve this on the dynamics or the input into the DOP network, right? Into this dynamics network. And that really isn't what we want to do, right? So we actually want to be working on the data itself that's within dynamics, right? So what we're seeing now is actually noise that exists within dynamics that is updating constantly. So one thing to keep in mind here that's it's slight, but it's super different about what's going on here is that this noise field is relative to the current position within the simulation. The previous one we brought in was relative to the noise field that was imported into dynamics, right? Into DOPS. So that noise field stayed static based on the original position of those points. You could do the same thing if you had the fall off. Let me think. You would have to have it look at the. I don't know if you can actually do that. If you can use it from the. Oh, I'm going to clamp this as well. If you can have it look at the rest position. But if you set a rest position, I don't think this has that ability. But if you had noise, here, rest attribute. So if we did this, let's see here, and we add a rest position, this will be the same. So if we do this, store rest, we should now have a rest attribute here, right? So now it's actually going to be working based on that rest attribute. And so now this should look actually very similar to what the original one looked like. I mean, there's probably some slight differences, but basically it's working on that rest field, right? So it's working on the original position of those points and not on the animated kind of simulated position of the points, right? So the real difference here is that that we have these, it's not kind of creating these local clusters, right? So it's kind of a little bit more moved around because as it moves and mixes, those rest positions stay the same, but their actual point positions move around. So that's kind of how it looks with the rest. And then if we use the actual one, this has these more localized pockets. So just know that difference is there. And you can see how this is like under the surface here, we're kind of getting these attributes and stuff like that. So, okay, so we've got this sort of doing its thing now, right? So now we've got this in simulation space. We've got a fall off in here that's working. We can just adjust this fall off in here. We don't have to be jumping back and forth. We can just do it all right here in dynamics. And the other stuff is just, it exists still, but it's not doing anything because we're only using our DOPS setup. So the other thing that we should kind of talk about is what if we wanted to do something kind of like, I think, who mentioned that? Like Nazio mentioned that about how would you do it with a more, not so much like remapping the attribute, but multiplying it by something, right? So that it was kind of working a little bit differently, right? You're multiplying it by the original scale and not just absolute values, so that no matter kind of what the P scale is coming in, you're always multiplying it and doing things like that kind of relative to that value and not something that's so specific and hard-coded. So this, instead of doing this one here, what we can do is we can do a MOPs apply attributes. And so for this, what we can, so the other one actually, let's see if this works as well. This should work actually. So let's do MOPs, MOPs transform modifier, right? So this should actually work as well. I think it needs to be in local space. And yeah, I think that should all work. Let me just make sure that this is all right. MOPs falloff dops. Cool. I think this should work. There was a little bit of weirdness that I was noticing with this with Henry, and a bug has been submitted, and we'll see if this is. Yeah, I think this is the same. I think this is what I was running into before. Let me just make this a little more extreme and see if we notice it here. No. Okay, that's doing it. That's doing what we wanted. Cool. Oh no, actually it is. They're all kind of creeping up in size, it looks like. Yeah, so this one is doing stuff a little differently from what the other one was doing there. I think this is yeah, without the local space on, we run into this kind of creeping up problem, which is not good. So we want it to be in local space. And I was kind of running into a little bit of weirdness with this. So this one works and it does kind of what we want it to, but I think a better way of doing this is actually using the apply attributes, because I feel like I get a little bit more control out of them, and we can kind of have something a bit more interesting from that. So another thing too that I want to do is, instead of doing this noise falloff, which is a little bit kind of heavy-handed because it just kind of runs around and kind of does its own thing, let's do the MOPs shape falloff. I just want to do that. So let's do this. And let's do a shape. We'll do a sphere, maybe 0.1. And again, here, we don't have to actually leave the dynamics context to be able to work with this. So now we've got this sphere in here, which I think if we just go up to 0.2, that should be fine. Yep. And so now we can actually animate this right in dynamics and not have to mess around with anything else. So now it's just applying it globally, which is fine. We're gonna adjust that. But let's do this. MOPs falloff dops. Can preview that as well. Okay. So now what I'm going to do is I'm just going to turn off the dynamics here. There's a little button down here. I don't know if you can actually see it. Sorry, it's like kind of down below here. There's a little brain icon. You just check that off. It has a little box. You just click it. Puts a little stop, kind of do not whatever. So that basically turns off the simulation. And so what we're going to do is just transform this around a little bit in here. So let's kind of just grab some options here. So we'll do 24. I'm just going to keyframe those like that, and then go down here, and we'll just kind of move this around a little bit. And what I'm going to do is just, oops. So we'll maybe move it here, like this, and then maybe one more, and then have it go back over this way. All right, so now let's turn our little brain back on down there and see what happens here. So this should now go across. Now, nothing is really happening too much here because we're only giving it a little bit where it's actually able to scale up, right? So we're only giving it like a short little spurt here. So let's try this. Let's try 1.1 and see what that does for us here. So the thing to notice about this MOPs transform, right, is that anything that stays within that scale, like you saw at the very end there, this point basically stays inside of that fall off and keeps getting it added, right? So each frame, we're kind of adding this, or kind of scaling it up by this uniform value, right? So this is very much like, this is very much a way that you can kind of always add to your, to your scales or your translations, anything. Like we could also do this where we could have it jump up in the air or something. So we could do, I don't know, let's see if this will add a little bit to it, but let's see here, start animating and this will pop them up in the air. I mean, it's ridiculous looking. Let's do it a little bit less. Let's do 0.75. There we go. So this should now pop them up in the air and scale them a little bit. And they're going to do that and kind of fly around and, do whatever. But remember that because we're kind of in this simulation space, any spot where these points, these spheres go back around that that scale, that fall off area, they're going to continue to get that added to them. So let's reduce that a little bit. So there's obviously a lot that you could do with this, right? Like there's a ton of different kind of conceptual things that could be kind of done with something like this, right? And maybe you want to be able to kind of always be able to scale them up, keep scaling them up, keep scaling points up and stuff like that. But what if you actually wanted to not scale them up and just basically, just have them go back or something like that, right? Well, you kind of need to have a way to be able to, give it a target or something to be able to go back and forth to, right? Because if you're just multiplying, it's hard to know, if you're multiplying per time step, it's hard to know, maybe where your original scale was, things like that. So what can be really nice is you can actually have a way to do that, and then have maybe like a target that you're gonna look to that's gonna have those attributes, right? So what you could do, just kind of simply, is you could. So this, let's just rename this here. So this is going to be continuous p scale increase, and then this is a spherical fall off. Okay. So here's our continuous p-scale increase, but let's just jump up here again. And what we could actually do is, instead of having this stream that's coming in here that has our p-scale on it, what if we just did a attribute adjust float, and we just did a multiply, maybe a constant value of something like 1.1 to the p-scale. This is actually already set to p-scale, so we can see here, there's our 1.1. Let's make it a little bit bigger. Let's do something like, and this actually is cool because you can see visually like how big they're going to get, right? So yeah, maybe we'll do like 2. We'll do something like that, right? Have it go up to 2. We'll see where it goes. But so let's just do a null here. And we'll say this is going to be p-scale target. Something like target. And what we can do is we can use this as a target for adjusting attributes in here. So I'm just going to turn this off. I know we've got a lot of stuff in here, but I want to make sure that you don't have to kind of recreate these if you want to set them up from this file. So let's do the apply attributes now. And so now this one is a little bit, this is kind of the most advanced way of doing this, right? Because we have kind of an incoming set of attributes that we want to work with, right? And a lot of times, if you're working within a standard, DOP network, if you're working in a standard DOP network and set up a Vellum solver from scratch, the way that you really should do this is just stick this into the second input. You don't even need to have a target or anything like that, because then you could just look at the second context, second input, basically. But within the Vellum solver, that isn't the case. We can't just say second input, because the second input to the very top is actually the constraints in, and it's a little bit more rigid in how kind of it's set up from that standpoint. So we're just going to really kind of specifically state where we're going to look to. So let's make sure we're looking at MOPs falloff DOPs so that we know that it's this one right here. And let's go to our inputs. We'll say SOP, and let's look for it. So now one thing you'll notice is whenever you bring up this operator thing, you're actually in kind of inside of the Vellum solver, inside a couple levels deep. So let's just go back up here. Here's our p-scale target. We'll accept this. And we're just going to turn off everything except for scale. We don't really need to do any translation or rotation or anything like that. We just want to update the scale. So that's all we need. And I don't think there's anything else we're going to need to set right now, but we'll just leave it like this and kind of see where that takes us. Oh, the difference between SOP, like the SOP vellum solver and the dynamics, the DOP vellum solver is really just that the DOP one you normally set up yourself, from scratch or from like from a shelf tool or something. It's quite a bit more flexible, as in you could do just about anything you would want to. The DOP or the SOP one is, if we actually look here, this is actually the dynamics network for our SOP solver, right? So this is our our vellum solver here, and we're in a DOP network inside of it. And this forces is actually where we jump in when we double click. So when we double click on this vellum SOP solver, we dive in like a few levels deep, right? So when we come in here and we go up to DOPNet 1, we see this is the actual dynamics network. This is how you would set up a vellum, dynamics network from scratch. You'd set up a vellum object, you'd give it some colliders like a ground plane and static object, gravity, you'd give maybe some forces and sources, and here we have a pop wind as well. So, and gravity, you need a gravity force. So this is how you would set up a dynamics network just from scratch. Now, if we go in here and go up another level, there's actually even another secondary kind of level here that's a geometry network, where it cleans everything up, messes with a bunch of attributes, repasses those back for the output and stuff like that. So there's a lot going on in here beyond just a dynamics, a DOP network. Here's the DOP network right here. So this actually sits in one level deep. So if I was to allow the editing of contents of this and jump inside, okay, now we've got this network, and then we're going to jump inside again to our dynamics network, and then we jump in again to our forces. And that's where we were doing all of our work, right? So I'm just going to match current definition from here just to make sure that we're back. Oops, we're back where we were. There we go. So basically, if you did a just straight DOP network, the difference between the force and the source output. Yeah, sure. So the reason that there are difference here is that the pop force, this force output here, is applying per point forces. And the source is saying this is where you want to add maybe new geometry or something like that. However, let's just look at what I was just talking about here. So let's do let's do this. Allow editing of contents. I'm going to go up one network here. So this forces is where we've been just doing all that work, right? So if we look, output 0 is force, output 1 is source. So this here is output 1, so 0 and 1 basically. So if we look, this is coming into the vellum solver, right? And this vellum solver has two different nodes where it can have these dynamic operators plugged into it, right? So we also have this little sources here, and this just has a little bit of data inside of it. It's nothing really to worry about there. But basically, the source actually comes out and goes more or less right into this source input for the vellum solver. It's actually called post solve. And the particle force is the other input. A lot of times there's a pre-solve, there's a velocity update step, and a post-solve for dynamics operators. And what a lot of times it's basically one thing happens before everything is solved, one thing happens while it's being solved, and the last one happens at the end. Like I think Flip has that. Let me just see here. Flip solver. So here's a flip solver. And it has a particle velocity, volume velocity, and a sourcing. So they've actually changed it a little bit over time. But anyways, there's these different kind of stages of your sim. And so really you could put your forces probably into this post solve, but it wouldn't really do what you want it to. You want to bring it in at this particle forces, and you also wouldn't want to be sourcing stuff at this particle force kind of stage. You want to do that in the post solve stage. So Basically, it solves everything and then sources, right? Because you don't want to be solving on the first frame or else things will move and do some different weird stuff. So that's kind of what's happening inside of here. And I know it can be a little confusing. This really isn't the point of this all, but I'm just going to click match current definition. It's going to lock us all back down here, and we'll dive back up to the top here. So I'm just going to say set. So hopefully that helps a little bit. Hopefully it's not too confusing. Yeah, it's a little bit weird. I mean, I wouldn't worry too much about it, but basically it's just different inputs into the solver that are coming out of here. Sometimes the same thing can work in both of them, but it hopefully that makes a little bit more sense. All right, so let's mess with this apply attribute, see what happens here, because now we're sourcing from that P scale target. We're going to apply this to the geometry, and we're just going to do the transformation, and we're going to do it in the set mode, I think, for right now. So let's do that. Let's see how this works. Hopefully this will work just fine. Yep. Cool. So now one of the interesting things that you'll notice is that we actually can't have these spheres get over the scale of that P scale that we set up, right? We have small ones here, right? There's some small ones that are getting kicked out. There's some that have gotten to the full scale, that were kind of the goal scale. But we don't have any that will go above kind of that P scale value that we set. So here we have 0.025. If we go back up here and look at our P scale target, 0.025. So now we're just setting it based on that fall off, right? So it's just in a set mode. And so it can only be set to the percentage of that fall off that it hits, right? It's actually not going to go back, right? We don't have a way to go back unless we had a negative fall off, right? Or something like that, which you might be able to do. I actually hadn't thought of that, but until I just said it now. But I think if you had a negative fall off, it would probably go back. But let's play with this and also do it in the multiply mode. So this, I think what we're going to see here is that it's going to come up and go back down. I hope. No, it goes the other way. Okay. So you don't want to do it in the multiply, in this case, in the multiply mode because, right. Because we're actually multiplying it by that P scale. So that's what we're actually working with. So in this case, if we wanted to use it in the multiply mode, let's just see here. So let's do this. Instead of multiply, let's do set. And so we want to multiply it by a value. So let's just do like what this is ridiculous now. This kind of doesn't really visualize anything, but let's just multiply it by this constant 1.1 value and see if that works. I think that'll do something. Yep. Okay, and let me just see here. One more thing that I want to try, actually, now that I'm thinking of it. Let's go back here. Reset this to, what did we have it to before? Sorry, just going back here to the multiply. Just undoing. Come on. Match current definition. Let's do this. Okay, so that's scaled to 2. Great. Okay, that's what we want. All right, so let's do this. Let's check this out, and let's do our fall off and say... What if we do this? Yep, it does make it go down. Okay. Yeah, I was thinking that that would work with it going up and coming back down, but it actually doesn't. Why does it not do that? Did I miss something here? No, I guess that is the way you would just set it. So I think if you wanted to do something that would have it kind of go back and forth between a certain range, you would want to do something maybe that you were explicitly setting it to, like this, fall off to P scale here, right? So if we did something like this down here, and this will give us that DOPS, and we're going to get our in and out range here. And I think if we do this, yep. So if you're doing something that you wanted to kind of go back and forth between, you'd want to do it like this, so that it's going to scale up when you're inside of this fall off area, and then when it goes back, obviously it's going to come back down. So if you wanted to kind of go back and forth, using something like this where you're doing a fetch attribute is probably going to be a bit of a better way of doing this, right? And obviously we could, change the way that this is, the scale is and how the fall off is and all that kind of stuff. We have control over that here with the fall off and with the shape, right? We can do the inner and outer radius. So there's a lot of obviously different controls that we could do here. We could up this to 2, make it a little bit of a bigger area that it's going to go through. And now we've got kind of more of these particles that are getting kind of swept into that, but then they're also being able to kind of go back down in scale as well. So just kind of thinking it from it that way, the transform modifier and the apply modifier are going to be a little bit trickier to get it back to the actual original size. You might be able to kind of tweak with them and maybe tweak them and be able to make that happen. But I think the best way, if you wanted to kind of go up and down in scale, is to use this fetch attribute. That's kind of, from what I'm seeing here, kind of the best way of going about that. So this is kind of the really, this is obviously I've done a lot here, but just with a couple nodes, you can kind of do a whole lot with this simulation and another or with these MOPs plus nodes. Another thing I should say too is that these are evaluating down this chain, so that's why I'm making sure that the fall offs are always kind of at the top, and that things like the apply attributes or the transform modifiers are going to be lower at the bottom. So now we got a really big thing. Too big. All right, so we'll do that, just 0.1. Cool. So this is kind of how you would do something with where you have, maybe just like a set container of something. You want to scale it up. You want to kind of play around with the size of these things and yes, Vellum does run on the GPU. It is, the part of it does. It's OpenCL. So yes, part of it does run on the GPU. So we've got this example here, right? So we've got something sort of going on here. This is our grain simulation, right? So if you saw the post that I made, basically what I did was I did a a fracture simulation, and then had it kind of move between some different basically between some different from like a tower, had it break apart and then reshape back together. So let's now set that up and kind of see what that would specifically look like. So let's do geometry here, and we'll say sim fracture. Yeah, we'll say fractured tower. I don't know, something like that. All right, I'm gonna hide this. Let's go inside of here. All right, so let's do a box. I can type. Let's do a box. We'll do it 3 I'm going to do a match size. Minimum, we'll say place on ground. Cool. All right. And then for this one, we can kind of make this look a little bit nicer, but first I'm just going to do kind of the simplest version of this, and then we can go from there and do something a little bit more interesting, like from a visual standpoint. You know, I had those colors in there and stuff like that. If you saw, like I said, if you saw that little video that I put in on Twitter or social or whatever. Okay, so let's just do a Voronoi shatter first, because that's going to be Voronoi fracture, first. So here's our geometry to fracture. We also need some points. This was where I did volume to, no, sorry. It's the other way. Points from volume. So I'm going to grab that. Don't need that many. Let's do 0.2. We're going to jitter it a bit. Let's say maybe to 1. So for each of these points, we're going to get a piece, basically. So when we connect this in here, we're going to get a bunch of pieces here. So let's just maybe bring this down a little. If we had it exactly, that would be kind of goofy. Let's do a tetrahedral, so that'll be a little bit more, you know, honeycomb-ish. So let's do something like this. We can kind of control how many points we get just based on, you know, the separation here. This is 1200. I don't know. Something like that's great, I think. 700. Nice. All right. So we've got our fracture. So let's now take this and bring this into a RBD. So let's do on RBD configure. So this is basically just packing it. And this is a very similar process to what would be done with a MOPs convert. Except for this, we don't need to compute the normals. But what's going to happen here that's a little different is we're going to add some attributes that are ready for simulation too, right? So, so what you could do the MOPs convert, add the properties you needed. You kind of do this a couple different ways. It'll be fine sort of either way. But what we have here is, we also have an ID. So we could add that in as well. But we have rest positions. We have a bunch of different things here. So it's kind of your call which way you want to go through it. But I think just going with the RBD configure makes a little bit more sense, because if we do an RBD bullet solver next and just go in here, add a ground plane for our collision, and yeah, that should be it. I mean, we're going to get a simulation right now, right? So we've got a sim that's working, right? So this is going to work. If we did this, I don't think it will work. Oh, interesting. It does work. Go figure. Okay. Well, your choice. If you need the RBD stuff, you can use this. If you want to just go through the MOP stuff, you can go through that. Sometimes Houdini makes a liar of me, so there you go. But either way, works fine. Will work for you. If you want the constraints and things like that that come through the RBD setup and stuff like that, do it that way. But anyways, so we've got this solver here, right? So I guess we'll just use the MOPs thing for right now. And if we need to switch over to the RBD configure, we can do that as well. I don't think I set anything else on here. Oh, yes, I did actually. So it actually would make more sense, because what I want to do is actually set this active to 0. So I'm going to just keep changing my mind back and forth. Let's go this way. Just grab those 3, shift click all those, drag them in there. So what I want to do is set this active to 0, because this is going to make it so that it's not doing anything, because we want to give it kind of an initial little kick, right? So actually, I was thinking that would do it, that there was also, I saw that in there when I was typing, that there was a noise thing, and I was like, can I do noise from this? No, not, I mean, I could, but okay. So what we want to do is, well, first of all, let's add some IDs in here. So let's do this. Actually, we could just do this, I think. Now that I'm thinking of it, I forgot this had, yep, perfect. Let's just do the MOPs convert. We'll add that in. And so now we have the MOPs attributes on here as well, but we also have the active from the RBD configure. So this wants to pack everything and mess with it that way. That will be, actually, sorry. What we actually want to do is put it on this side, because this is going to be, if we look here, this is our proxy geometry, and this is actually what the simulation is going to be done on. This is our full high-res geometry. So we'll get to that in a second, but this is actually what we want it to be done on here, like this. Anyways, and we're going to do a bunch of stuff on this channel, not over here. Anything that we do on our actual geometry is just going to be kind of the actual render output of it, and nothing more than that. So, okay, so we've got our MOPs convert in there. That's adding in our ID and things like that. But what we need to do is add some sort of an attribute that's going to allow us to kind of activate these things, right? So let's do that. So we've got our MOPs convert here, and let's do a MOPs fall off, and let's do a shape fall off. And I'm just going to rotate this so that we're sitting, control, like that. I think that's what we want. So this is one, nope, other way. So I'm going to just do this -90 rotation. So we can see now the fall off is 0. You can see here. And as I bring it down, we're going to have these go up to 1, right? So what I'm going to do is allow for this to set our activation state of our pieces here. So let's take it here in the Z axis, make this a little bit shorter. Sure, 0.2. All right, let's just keyframe this. Now, one thing to notice is that these are packed fragments. So even if we preview it, it's not going to show up the way we want it to. It can't color properly in that packed fragment way. Wanted to find out what must you always unpack a geo to be able to render it. Is the way to just render the packed geo. You don't have to unpack geometry to render it. It depends on what you're rendering it to, I guess. Anything within Houdini, I don't think you've ever needed to unpack geometry to render it. But nowadays, when you go into Solaris and into Karma, you can have packed geometry, and that's totally fine. It's no problem at all. So you don't have to unpack it to render it. It's just that when geometry is packed, you don't have access to the individual primitives to be able to make modifications to them and stuff. So we don't have the specifics, the specific primitives to be able to select and mess with and stuff like that. So that's why a lot of times you want to unpack it if you're going to do other things to it. UV it or texture it, or, add more attributes to it, tweak it, do whatever. So when it's packed, it just exists basically as a single point that has its attributes stored on that point in memory. So hopefully that makes sense. Okay, so we have this. We're going to animate this fall off. So let's just do this. Let's take translate. And we'll bring this down to the bottom here. I'm actually going to middle click on this and drag it back. All right, so that should be our fall off, right? So we've got this attribute that's coming in and animating. We can just animate it right here in our SOPs if we want to, and then go inside of here. And this is a little different because this is a rigid body. We have a pre-solve and a post-solve. This is sort of what I was talking about before. Forces go into pre-solve, and maybe sourcing and things like that would go into post-solve. So anyways, we're going to just work on this pre-solve right now. And if you remember, we can do a fetch. And what we can do here is we can say, I'm just going to leave this as MOPs fall off. I don't want to like make a whole bunch of them. If I need to make another MOPs fall off, I'll just name it something different. But this is just the default coming in. And I'm going to say active. And this is a size of 1. And we're going to do the input from, let's see, how did I do that before? Sorry. Sorry, just waiting for one thing to cook over here. All right. Destination type. Yeah. Okay. Match by name. Okay. So this is where this gets a little bit weird, because as we can see, this is actually going into this third input here, right? But when we come inside of here, I'm just going to say first context geometry here, because this is actually going to read from our first context geometry. And I'm going to set this to int because it's actually going to be an integer attribute, and we can match it by attribute. And in this case, let's do it by name. And this should have a name on it as well. It does. Great. And I think that's all we need for that. Let's see here. Yep. Cool. So we've got that working, but we want to give it some velocity, right? We don't want it to just kind of fall down and fall to pieces, basically. What we want to do is actually have it, shoot off a little bit in space, right? So let's have that set up, and let's get that working. So for that, we need to add some velocities onto this, right? So let's do that. Yep. Okay. So let's just do a point velocity here. And what I'm going to do just to visualize this is do an extract all points, just so I can kind of see these without, so I can see the points. Hello? Ooh, looks like we got a little stuck. Possibly. There we go. All right, so I'm going to do that. I'm going to turn on the little visualizer here for this, our little trail. And let's add some point velocities here. I'm just going to say keep incoming. We don't need to do anything there. And let's just add some maybe conical noise to this. And so let's scale it a little bit. Maybe we'll do, I don't know, maybe we'll do 3. The cone angle, That's basically how far out it's going to be. And then I'm just going to do this directional bias, and I think we should actually be able to adjust this so it's kind of a bit flatter here. Okay, what did I do here? Let's see, set to value. Yeah, it didn't really matter. Okay, just making sure I have this relatively similar to how I had it before. So now, if we take a look at this, just with all the same settings there, nothing's really happening here. So it's kind of interesting. And what you'll notice is that we need a way to be able to kind of have this velocity be kind of added into our simulation properly. And what we're actually running into is if we watch this and we go to the velocity is right here, we have our velocities. And if we go to frame 1 or 2, they all get set to 0 because they're not active yet. None of these are active. So there's probably, I don't even think there's any that have been set to active yet. So if we look and see the active ones, there's probably a few. Oh, sorry. Did it the wrong way. Like that, maybe. Nope, we don't have any active ones yet. Let me just see what's going on here. Active. Okay, there we go. There's our active. Right? And so they have to be active in order for that velocity to kind of come through. And what it's doing is it's basically just saying, okay, these aren't active. Let's just zero out the velocities. They're not moving anywhere. So then by the time they do get activated, their velocity is 0 and they don't have an initial velocity to go to. So what I did was one really simple thing here. I set up an attribute called vrest, velocity rest, right? So what we can do here is, can we actually do this? Can we do an attribute remap? Let's see. Let's see if that'll work. I did this through Vex, but let's actually see if we can do this. vrest. Is that going to do it for me? Nope, because that's only a... Okay. One more thing. Let me just see. Attribute rename. Will this work? Yep, that'll work. So let's do this instead. And we'll do that, vrest. So we'll just say, oh, actually, sorry. One more thing. I'm just realizing. Does this have a rest? No. Kind of just thinking through things on the fly here while I'm going. I was thinking maybe this had a thing to store a rest velocity, but it doesn't. So let's just do this. We'll say store rest velocity, and then we'll say velocity noise. All right, so we've got our velocity noise here. We've got our stored rest attribute. Now we should have no velocity on this. We don't see any trails coming off of these points, so we don't have any velocity going on there. We'll come in here, and now we just need one line of code. We'll do a pop wrangle. Now these are all points. Remember, these are all packed geometry, so they're all points. So we can just literally do a pop wrangle in this post solve. And here we're going to say, we can just simply write one line of vex to make this nice and easy. We can say v at v equals, sorry, v at rest. Oh, sorry, v at v rest. And we're gonna set this to the group, and we're just gonna say at active equals 0. And so what this means is if it's not active, we're just gonna keep updating the velocity with this rest attribute, right? And then once it's active, it'll have that velocity in it, and it'll just be done. And it's going to be active. This won't work on it anymore, and it'll just be able to do whatever it wants to. So this is basically just saying update v from rest. So let's just take a look at what this is doing. So this should do what we're wanting it to, and we're going to see there is some velocities added in there, right? So we're starting to actually see some initial velocities added. So that's cool. It's starting to do what we want it to, but let's give it a little bit more velocity just to see if this will actually do what we want it to. Let's go to 7.5. There we go. Cool. And let's add in some pop drag and pop drag spin. This is just going to make sure that there's a little bit of dragginess to it. So we're just going to add in some little bit of air resistance for both of these. This will just give it that little bit of drag to kind of make sure that it, does kind of what we want it to. Let me just set my my velocities based on this over here. I just don't know why. Didn't quite get what I wanted to from that. Conical noise 7.5, 75. I think maybe I zeroed it out a little too much. Okay, let's try that instead. Yeah, there we go. That's a little more fun. Cool. It's obviously going to look a little different because it's all just Voronoi fracture pieces different from what I had done before. But we're starting to get somewhere here, right? So we've got our extracted values here. It's all doing its thing, right? And those drags will just make sure that like any little pieces that are kind of flipping around and doing some weirdness, they'll just kind of help bleed some of that energy out, right? Just little details to kind of help sell the overall effect. So there's our base part of our simulation, right? So we're using a mop shape fall off here, right? With a little bit of velocity noise, nothing too crazy. We're just storing that rest value so that we're able to kind of recall it when we want to. And we literally just have one wrangle that's doing this little bit of code for us, basically. So, another thing that I should mention is that you could actually do this like this. This is like kind of the weirdness of how this works in dynamics. So this should work basically the exact same. Yep. So a lot of times in dynamics, you'll see this where just these merge basically are just like relationships to be able to just basically merge these things together. And it sort of evaluates left to right, top to top down. It's a little hi Mittel. That's nice to have. That's the first time I've seen a LinkedIn icon in my chat. That's cool. Welcome. So yeah, the active equals 0 group is basically just looking at that active it's just looking at that active attribute, which is just an integer attribute. And so basically we're not doing like any if statements or anything like that. We're just basically saying the group is the active equals 0. It's just like saying at name equals or at ID equals. It just a single equals is fine for that. We're not really evaluating it like an if statement. So it's not like a logic type thing. It's just basically setting the group based on an attribute. So yeah, just a single equals in this case. because if we did it with a double, I think that would freak it out, I think. No, they both work. I don't know why the difference there. Yeah, but I don't know why that's, anyways, it works both ways. So, I think if we didn't have this, it would do that. Just keep adding the velocity in forever. It would just fly away to infinity. So, yeah, they both work. Cool. Sometimes I don't even know why these things work and don't work, but you know, there you go. But great question. Thanks for bringing that up. That's a great question. Okay. So the last kind of part of this little, group syntax is its own thing that looks a little like Vex or HScript, but is a separate thing. Oh, hi. Oh my gosh, Henry, my brain. There you go. So there we go. It's its own thing, and both work. And I don't know why both of them work, but they do. So cool. Everybody, go check out that link. Okay, so the last thing I'm going to do is we're going to set this up to actually give us a sorry, just thinking here. We're going to basically set this up to be able to give us that kind of goal position where we spell out a word or something like that. So let's set that up. I'm going to get rid of this since this was just for visualization's sake. So we have our MOPs all converted and done here. Cool. We're going to work above this because this is kind of our, maybe we'll just give ourselves a little thing here. We'll add a null. And we'll just say initial velocity, initialize velocity or something like that. And then we'll work over here and do some more stuff. So I'm going to grab a little MOPs plus thing. There's a typography thing that you can use. There's a nice little font type SOP here, which is cool because it's got, it does all the extrusion for you and everything like that, which is very nice. It's got a bunch of controls and things like that. So I'm just going to make this a little deeper. I think I'm going to do this with, let's just do regular Lado. Cool. And then what we're going to do is we're going to unpack this because we want actual geometry. Actually, can I do that here? No. Okay. So we're just going to unpack it to make sure we have geometry, and we'll say MOPs move along mesh, which basically is just giving us a way to kind of stick these to the mesh here. Why is that yelling at me? Oh. There we go. Okay, I just needed an N attribute. So let's make this a little bigger. Let's make this typography a little bigger. So let's maybe do font size of 2. And I'm going to give it some tracking just to space it out a little bit here. Maybe like that, something like that. And let's also move this up a little bit. So I think global transform, bring this up like so. Maybe to 2. Cool. So obviously these won't be able to get in these exact positions because they're all kind of overlapped and things like that. But these should be randomized in that position. So we've got basically what this move along mesh is going to do is basically just stick these all to the mesh. And you can see this is starting to look kind of close to what I had put in my social. And yeah, we don't really need to do much else beyond that. Just a little scatter, move those points like that randomly, and we're good. That should be good for that. And then what we need to do is give this a way to know when it's time to transition, right? So we can do this a few different ways, and let's think here. So let's first do this in DOPS, and then we'll look at how we might do it in SOPs and kind of look at both of them and what the benefits are and kind of how they work, what maybe they're best for and what, you might be able to do better in each of them. So here, let's just give ourselves we're going to do another like little target here. So just do target like so. And okay, so that's like our target position. So let's jump back inside here. Let's get rid of these merges. It's a little confusing. Just drop those in like that. And let's do we're going to do the apply attribute. However, we do need our own fall off for this, right? We don't want to be using, we don't want to use the fall off or the MOPs fall off that's coming in here, right? We want to actually use something a little different because we don't want it to go up and down and all that kind of stuff. We want it to be based off of, maybe how this is, how it falls or, something like that. We want to be based on something else. So let's do that. Let's come in here and let's, first of all, I'm going to set a new fall off. We'll just call this target fall off. And let's just give this another shape fall off here. So let's do the shape. Let's do it linearly. And I'm just going to turn those off for right now and just let this fall down. We can just kind of look at what this looks like and where it's sitting. Cool. I'm just going to turn off the simulation and let's kind of say at 96, we'll take this shape fall off here. We'll move it this direction. Oops. Like that. And we can just click that, and then maybe to 168. We'll have it move over to here. Keyframe that. Okay. Turn my sim back on. Oops. Right. This is looking for target fall off, but I never changed this one here. So this one should be target fall off. And we need to set the actual target for this because I didn't set that yet. So that second context geometry is not going to work. Let's do a SOP and let's grab, oh boy, that's a lot of stuff. Let's grab our target. That's my problem. I didn't set that. So we're going to set this target, right? This is going to be the target position that we want these to go to. And so we've got our transformation here that's going to be working. We've got force updating and things like that. So this is going to be kind of how it moves into position. This is going to be what it's doing. Like in this case, we're telling it to move and rotate and scale and do all that kind of stuff. And then the fall off and inputs are basically saying, what's telling it when to move, and input is basically giving it its goal positions, basically. So let's run this again and take a look at this. And there we go. It's coming into place and things are kind of trying to shuffle back into where they want to be, you can make these, you can make these stronger or weaker using these different force multipliers, wind settings, things like that. So I think if I turn this up, it's going to kind of shoot back into position a little quicker. Yep. And then this should also give me an even stronger force to bring it back into position. Yeah, see, that really snaps it into position. It also overshoots like crazy. So it actually shot some stuff way off because it's trying to like bring it into position and actually like launches it off like, it actually like launches it off into the stratosphere here. So it's like gives it too much force to get it into position. So I can't remember if I turn that down, if that'll help. So what you're seeing is as they're actually going out of the fall off is actually launching them out of the fall off, and then they're coming back into the fall off. So they're like snapping back in. So it's kind of funky. But let's get this in a little bit of a better position here. So we're not going to do this so high. Let's maybe do this at 10. Maybe give this 2.5. Let's see. See if that's a little smoother. This is always the fun little portion of kind of playing around with. Yeah, so that's a bit of a slower kind of move into position. Let's see if we can maybe go a little higher on that translate force. Yeah, so we're getting a little something here. I mean, this is a little different than how I had it before anyways, but, we're starting to kind of get into that sort of world. It's kind of snapping into position and doing its thing. You can obviously, there's a lot of different ways that you could tweak this to get it kind of to snap right into position the way you want it to kind of be as, hard or soft as you want it to be. So maybe if we do 2.5 and up these to maybe 20. Actually, you know what? I'm just going to, because I really just want the position to snap into place. I don't really need the rotation to do that too much. Yep. So we're getting like a, bunch of different ways that this can kind of work. But another thing that you can do too is you can snap them by attribute, right? So you can actually have this when it gets within a certain threshold with the fall off, it'll actually snap into place. So once the fall off hits a certain amount, it'll actually kind of snap right into its location. And I think we actually might want to change this, but let me just see what this does first. Yep. And so what you can do here is you can actually have it go right into that, like basically that final position you want to, and just start ignoring collisions. So when this snap kind of activates, it's going to ignore collisions and just kind of go right into its own, its kind of final spot. And you can also do this by distance too, right? So the distance to where, where it needs to get to its final position. So when it's within 0.1, it's going to consider itself snapped and just kind of lock itself into place. And there's a little fade time here that we can adjust as well. So now these are, it's taking a little longer for them to snap into place because maybe they're not quite getting to 0.1. So let's do it 0.2 and see if that works. No, let's go a little higher. It looks like maybe some of them are snapping, but let's get a little higher here. See if we can't. Hopefully this is all making sense to everybody. You know, this is you know, there's a lot of little tweaky things here, obviously with you know, with how this specifically, you know, some of these little things work. Simulation's always like that, right? So you always have little parameters to kind of tweak and get into place and stuff like that. So so what we're seeing here now is the last little bit, it's actually it's like simulating, and then it's kind of sorting itself in, and once it gets within a certain spot, it just snaps into place. So this is a way that you could have it really closely kind of match up to that goal position that you want it to get to. Again, what you could do down here is you could give this a snap time of 2 seconds. And so instead of it just taking 1 second for it to go from its, you know, basically easing into the goal, you can have it ease a little bit longer. So there we go. Looking a little closer to what we maybe wanted to get to. However, what if we wanted to do this where we're actually building the word kind of from left to right, right? How would we maybe go about doing that, right? Because in this case, when everything falls down, how do we know how to reconfigure this word, right? So, you know, there's a few different ways that you could go about doing this, but let's look at this maybe just using MOPs only. Obviously, that's kind of what we're trying to go with here. So we have our MOPs move along mesh like this, right? What if we use this to create some sort of a fall off, right? So let's do that. Let's add a fall off to this. And so let's do another, we'll just do a shape fall off. And we'll do this like that. Oh, actually, I rotated the wrong way every time. Always the wrong way, just like a USB cable. You always try to put it in the wrong way. All right, so let's move this up like so. And I'm going to make this a little like half scale like that. And let's call this something a little different. Let's call this, again, target fall off. And we'll say target fall off stops so we know where it's coming from. All right, so if we remember, this fall off should go from 96 to, I don't know where we had, let me see where we had it here. 168, looks good. Let's try to do the same thing here. So we've got this target at 96. Well, let's just set the translate there, and then at 168, we'll bring it to the other side. Cool. All right, so we've got this fall off here. Let's say rebuild text. And so here's our target, and we've got this coming in here, right? So we need a way to be able to get that attribute to come in, right? We need that attribute to be in here. So what we should do is just grab another fetch, right? So instead of this being target fall off, we'll just hide that, and we'll do another fetch. And let's do this. So we're going to say the source attribute is going to be mops fall off sops. Or sorry, target fall off sops. My bad. And we're going to go in here. we'll do the same thing, target fall off SOPs. And then this we'll just call target fall off. And so that should all be good. We should be able to match it by ID because we have IDs here. Actually, no, sorry. Should we match this by name? Probably by name, actually. I think that was something that Henry had mentioned with rigid bodies, that you want to do it by name. Okay, and then we're just going to look at that same SOP field for the target. And now we should be getting in that attribute animated from SOPs, and it should come in. Let's see if this works. Let's see if I did this right. Fingers crossed. Looks like it. So what we're doing is we're taking that animated attribute, we're bringing that in through a fetch attribute and bringing that into our dynamics network right here with this MOPs fetch attribute. And obviously that's all kind of controlled. That the fall off is all controlled in SOPs. So the yes, I was gonna say I don't think there's any way that we can do that here. No. So really, I think personally that being able to build it basically from the word itself is, I think, a little bit more of an interesting effect than doing it from within Dynamics, because when you're within Dynamics, you're kind of limited as far as setting the fall off sometimes, or at least in my experience, you're sometimes limited by where the pieces are, right, physically in space, right, because you're trying to do it from a shape or something like that. Whereas if you're doing it in SOPs at like a static frame, you're able to do it a little bit more controlled from that standpoint and be able to kind of build these pieces kind of back up. So I'm sure if I poked around and prodded, there might be a way to do that a little bit more efficiently, maybe in the Dynamics context itself, but this is sort of what I've found from this simulation here. So this is more or less the effect that you've probably saw me talk about on social media and stuff like that. So this is sort of how it works, and you just can control some different parts of it as far as how quick it gets into place and things like that. The last little bit that I did was quite simply just doing, instead of doing this with a Voronoi fracture, it was doing it with a material fracture. So actually, why don't I just grab the version that I did that with, and I can just kind of show you that in my finished thing instead of like building that all kind of back up. So I'll bring this over. This is kind of how I had set that up. And really the only difference here for how this one worked was that I grabbed these points from volume, right? I kind of started with an initial set of points here. So these are kind of the first fracture level. And then I just added a little point replicate in there. And then that was sort of the second level for my material fracture. So I basically just have two levels of material fracture. The first one is set by the original points, and then the second one is set by the duplicates. So basically I've got output group duplicates, output point originals, and that's just driving my like material fracture levels. Just I wanted it to be a little more even the whole way down, so that was a way that I found I could get that. Now I did this a little differently the way I set this up here, but basically here I just made sure it had a seed value for the noise. I basically set up a group based on the inside that was going to be orange colored. I then did a group combined where I named blue is inside minus orange, and this was also done by a random seed. So that's where this is coming from. So it's based on inside, but it's keeping by the seed value. And then I just set the outside to gray, the inside to orange, orange group to orange, the blue group to blue, and then ran this through everything that I did before. I actually did this I think, a worse way here. So kind of ignore that. But that was me just kind of screwing around. And then in the end, you'll see that this simulation, while, you know, the inside is all its fractured pieces and stuff like that, but the main simulation is still based off of this. Oops, that's not what I meant to do. I want to grab it down here. So if we look at this here, this is actually the geometry that we're working on. This is that proxy geometry that's happening on this kind of third input and output path here. So we're working all on these, you know, this just kind of, you know, convex hull shapes. And that's really what RB, you know, what Bullet wants. It wants these convex shapes to be able to collide with. And there's different ways to do that for more complicated shapes and things like that. But just know that that's what we're working off of. And then we're using that simulation to drive these final piece, you know, these high quality pieces here. So that's kind of the difference that we're, you know, looking at there. And we can either see the proxy, or we can look at the final geometry like that. So really this was the only difference, was just doing this material fracture and setting up some colors. I can throw this in, I can throw this on the Google Drive link, which if you want to, you can grab that from Houdini Hangout through the Discord server invite there. So if you're not on the Discord server, you can go there and get the link to all of the HIP files from the stream. So I'll put this one in there as well, and you can take a look at this and kind of play around with this as well if you want to. This has both in it as well, but this is the actual one from tonight. And so yeah, hopefully that all makes sense to you guys. I know there wasn't quite as many questions or comments tonight. Hopefully everybody was following along pretty well and this made sense. I don't know if you guys have any questions or thoughts on any of this stuff. You know, I know it can be a little complicated, but hopefully all these tools make it a little bit simpler. I mean, we're not setting up constraint networks. We're not setting up any crazy stuff like that. We're just really working with falloffs. And yes, for this specific thing, yes, it would not work without MOPs Plus, but you could obviously within just regular Houdini make these things work. You know, like that is truly how you know, you could make any of these things work with using the standard MOPs tools and going in and you know, you could make your own way of doing this in Dynamics using the MOPs falloffs in the SOPs levels. So there are ways that you can do that, obviously. But in this case, yeah, MOPs Plus is really what I'm showing here, how this works in this setup. So anything in Dynamics with MOPs is all going to be MOPs Plus. So otherwise you'd probably be doing a bunch of wrangles and things like that. So yeah. Oh, Apoxia, you have a question. Would you recommend any tutorials for procedural modeling? I think, let me just look here. I think there's this thing called Polymarvels. Oh, you're asking about, I think, procedural modeling, though. Yeah, procedural modeling. So, I know. Yeah, I know that I've seen Igor's stuff about, so Polymarvels is a channel. He does stuff with like modeling and things like that. But I think this is mainly, I think this is all destructive stuff. So he's doing it really more, you know, standard modeling procedures, procedural modeling. Let me see here. Let me see. What about, I'm just wondering if we have any on here that I could recommend. Let me just go here. Oh boy. Nope. Sorry. Okay. Let's see here. Not sure if there's any that I could specifically... Yeah, I mean, honestly, I would take a look at some of these on here, on our tutorials. I can't say that I've done any of these. Like, modeling is not my kind of go-to. Oh, that's a great suggestion, Henry. Yeah, the Houdini battles are kind of cool too. Yeah, it's not exactly a tutorial, that's true. But yeah, those are pretty neat. But yeah, I think some of these things might be interesting. There's going to be a lot of procedural stuff in here. Igor's stuff is great. He's a really good modeler. He does not procedural modeling, but yeah, it's kind of hard because I think there's like kind of levels of since everything is procedural, sometimes people aren't like, oh, this is a procedural modeling thing. But yeah, just something to, I don't really have anything too specific, but hopefully those will help a little bit. But yeah, cool. Good suggestion, Henry. Thank you. Carlos. Ooh, you've got a big question. I will talk about that, but if anybody else has any other questions, I'd like to talk about those first so that we don't make people's ears bleed and then and then go back to like, how do we do this thing in MOPs? If anybody else has any other questions, I'd be happy to answer them. Carlos, I'll definitely reference that because I did watch that as well. Any other questions before we get into the concept of compile blocks and what Jeff was talking about in that Illum? All right. I'm going to take that as we're ready to get into the crazy. So, I'm just going to go away from my screen here for a second. I'm ready. Everybody's ready. So, what Jeff was talking about in that was this idea of compile blocks, right? And so, no, you're totally good, Carlos. No, it's a great question, and I'm happy to try to give, a more kindergartner's view on what all this compile stuff is, because I'm not a programmer. I haven't used Houdini for 20,000 years, but I do have hopefully some insight into what he's talking about to maybe be able to make some sense out of it. So what Jeff was talking about in that Illum was he's basically talking about the idea of having all of the SOPs, the surface operators, become able to be compiled, basically run as code, right? So that's what he's talking about in these compile blocks. So when you're doing a compile block, it's basically a way of being able to take your nodes and turn them into a block of code with parameters coming in, and you do a bunch of stuff, and it does a bunch of stuff inside of this block of code and then spits out the result at the end. It's much more efficient. Everything isn't living, live, Houdini nodes and things like that, but it kind of turns, especially for things like for each loops, it turns those into just a block of code that it can operate multiple times on your data coming in. And so it's a way to optimize and multi-thread what might not be that way previously. And so, Jeff was talking a lot about, what does that mean? And when he says SOPs 2.0, what he's really saying is, at least from my understanding, what he was talking about was having it so that every node within every surface operator, every SOP would be compilable, right? So, if we look here, it's actually really easy to see. Yeah, I think so. I think it's on the Houdini YouTube channel. Yeah, you'd have to look. I don't remember. Let me look. Let me see here. Pull it up on my YouTube and then I'll show you. Houdini. It's really weird to search Houdini and have yourself come up. It's very odd. And I mean like the stream that I'm doing right now. Why is this? Oh, I guess I should do side effects. There we go. It's weird. Okay, stop. Okay, it doesn't look like, I don't see it on there. Let me look at the side effects website again. Look in the talks. Talks and webinars. Yes, what Henry just said in the chat. Agreed. Yeah, I don't understand. I thought it was on here. Anyways, maybe it's not. Weird. Anyways, yes. What Henry said, concepts are the same as these compile blocks. But basically what he's saying is that there's this push to create compilable SOPs and things like that. But the problem is that obviously some of them are inherently oh man, looks like something's going on on Twitch that you can't post quick enough or something. I'll have to look into that. Anyways, so what we're looking at here, sorry, I'm like trying to do 10,000 things here. Just want to make sure yep, there we go. So like when you see this little icon right here, that basically means that something isn't compilable, right? And so because of that, you can't put that inside of a compile block, right? This is a standard SOP, but because of it being, whatever number of reasons, it's not compilable. And so sometimes it has to do with dependencies and different things like that. So so I think it's not like everything's going to change with SOPs. That's not really the idea of what he was talking about there. It's just more so that it's going to be a kind of underlying thing that changes how SOPs are able to be executed. One thing that's really interesting with these, with the idea of SOPs being compilable, is you can actually run them in the viewport in a Python state in the viewport. So you can actually do like I was doing a little tool where I had a font SOP that was running in through Python and displaying text in the viewport for me to make it look actually nice instead of like, our little point numbers, like these little things here that you see that look kind of junky. So, yeah, there's a lot of really cool stuff that you can do with it. I wouldn't worry too much about it. It's not like anything's going to like inherently change or anything like that, at least that I would have any idea about. But, yeah, I think that was what he was talking about. So hopefully that helps. I'm not sure why I can't find that talk anywhere, but there you go. So yeah, I don't know if anybody has any other questions or any thoughts or anything like that. Happy to talk about whatever, but if not, I think we might start wrapping this thing up. So I'll give you a second to formulate any more thoughts you might have or questions, but yeah. Another thing I just to suggest is if you go to the Discord server and you have something you would like for us to cover in one of these, MOPs Monday presentations, streams, whatever you want to call it, please go into the Discord and check out. Sorry, I'm just going to copy this link that Henry was trying to. Henry was trying to share this. There you go. Oh, that might be the compile blocks thing. Looks like he got it to work. Anyways, yeah, that's the same link. Anyways, so yeah, if you guys have any suggestions for future MOPS Mondays, happy to see those in the Discord server. Next week, I'm actually going to be away on vacation, so I will not be doing a MOPS Monday. Might be doing a stream on Wednesday. Just keep an eye out for that. I think I might not, but we'll see. Depends on when I get back and if I'm feeling mentally ready or whatever. Oh, sorry, Henry. I've got a vacation, family vacation. But we'll be back at it after that and go into October. So, Moses was asking, what advice would you give someone moving from C4D to Houdini? What advice would I give you? Well, I think the things that helped me the most, coming from something like cinema, where it's very much, kind of everything is happening in the viewport, right? Moving over to something like Houdini, where you've got a lot of things that are happening. Yeah, I like Henry's advice too. Yeah, he says don't do simulations until you understand SOPs and attributes. 100%. I think a lot of people think like, let's get into Houdini, let's do simulations and let's go crazy. And it's like, yeah, that's fun, but I think I would have been way more successful if I laid the groundwork with attributes, with understanding just some of the ways that Houdini works before I tried to get into like, how do I do a boat rising up out, a sunken ship rising out of the ocean or something like that. I think I would have been a lot quicker to get to like a production ready level. But I would also say, like, for me, it was helpful to just maybe this will sound scary, but hopefully it isn't. But like, some of the things that are really helpful to know in Houdini are like what a vector is, what's what does the length of a vector mean, things like that. Like, if you go and like just watch a couple of videos from like on YouTube of people just explaining some of those simple concepts like vectors and what's a float and what's an integer and what are these different things, like just knowing some of that vocabulary and being able to understand some of these, I mean, they're math concepts, but they're really, really simple and they're true for like every like 3D software. But in Houdini, they're so accessible. It's just good to know some of those little details, because in cinema, you don't really need to worry too much about that. It's kind of just what's happening in the viewport and just kind of screwing around there. But here you've got, in Houdini, you've got the, your geometry spreadsheet and you've got attributes that you're working on and all these different things. So just being able to know some of those really simple concepts, really basic, like mathy kind of concepts, and some simple programming concepts are nice to know, like what's an if statement, like what does that mean, and like some of those things are good to just know, because sometimes you'll run across a tutorial or something that seems like so scary because it's like they're writing a line of Vex or something like that, and you're like, oh no. But when you really just understand the really basic concepts of that, I think it demystifies it a lot. But certainly understanding, attributes, what that means, like, how the what the node network is doing and how that is laid out, what it means, how data flow. Yeah. Vex, you don't need to worry about it. You don't have to become a programmer or anything like that. Use a lot of, there's these attribute adjust nodes that are great. Like if you want to play around with attributes, those are awesome to play around with. They've got a lot of really cool ways to randomize attributes and do a bunch of different random stuff, add noises, things like that. Yeah. So I think some of that would be my suggestion, but I think Henry nailed it in his, understanding SOPs and attributes is a huge part of understanding how Houdini works. And really that's most of what we're doing here. Yeah, KG has a great point there. He learned a lot of that stuff from Applied Houdini. That's where for me, I got a lot of my real production ready stuff from Applied Houdini as well. Really good stuff. But again, that's different. Whatever. That's kind of a little bit down the line into simulation. Mark Fanter's stuff is awesome too. That's a great. His stuff is great. Carlos, you're just saying, when driving Vellum attributes with masks, which method is more efficient? SOP solver, geometry wrangle, or Vellum constraint properties? Vex expression. Yeah, exactly. Henry beat me to it. Yeah, the wrangle is always super, super efficient. They operate on a really low level, on a programming level. So they're able to deal with tons and tons of data at the same time. That's why you can iterate through millions of points and do different operations to them in sometimes fractions of a second. So yeah, definitely wrangles are the most efficient way of doing it. And a Vex expression is basically just Vex in the context of whatever you're doing there with those constraints and stuff like that. So, yeah, definitely a solver you're simulating, right? You're simulating to use a solver. So, that's always going to be kind of the most overhead that you're going to have in any situation. So yeah, definitely a lot of overhead with that. I only use that when it's something that you kind of have to. And I think you'll see in some of these nodes as well for MOPs, if you look in some of the help and stuff like that, like on the help cards, it's explicitly say this is a solver, like it's solving for this thing, or it's doing X, Y, or Z. And, that is, it's always going to be a little bit slower, a little bit more overhead. Sometimes that's the only way you can actually, especially if you're dealing with time and accumulation of attributes and things like that, that's sometimes the only way you can do it. So yeah. Cool. Yeah. We're, also just as a little side note, I was, chatting with Mark the other day, and, we're going to figure out a time to get him back on here to show some more of his, fun work, that, he's maybe done recently or whatever. So we're chatting about a time to get him to come back on the stream and show some more of his stuff. So yeah, should be cool. I've actually got a couple people that I've been chatting with about finding times for them to come, give us some of their knowledge and things like that. Wait, Epoxia, do you work with Mark? I'm confused. We've done cool things recently. Yeah. Yeah. Moses, I'd like to see Mark again too. I don't chat with him enough. Yeah. That was really fun. I loved seeing all that XFL stuff. That was really cool. Oh, awesome. Oh, you're one of his converts. Well, Welcome. Glad to have you around. Very nice. welcome to the cult of Houdini. Anyways, well, cool. Well, guys, if you guys have any more questions, feel free to drop them in chat, and we can talk about some more stuff. But yeah, like I said, next week will be a little bit of a lighter week because I'll be chilling at a lake house, just enjoying nature. And Wednesday though, we will have a regular kind of Houdini Hangout. If you guys have any suggestions or thoughts for that as well, feel free to drop into the Discord and put those suggestions there as well. But yeah, I think that pretty much is going to wrap up the evening, unless anybody has any last questions or thoughts or anything like that. But hopefully this gives you a bit more understanding of how to well, Black Voxels, thanks for joining us. Yeah, just here to chill and talk about Houdini and, answer people's questions and be able to do whatever. So thanks for joining us. As usual, if you want to join the Discord server, go to HoudiniHangout.com. Past streams are there. Discord server invite. If you want to find links to other things, they're there. But for this evening, I think we'll wrap it up and call it a night. And I'll see you guys on Wednesday, 2 days from now. And I'm thinking actually we might be doing that one at 6 p.m. as well. I feel like we're able to get a little bit better engagement and turnout at 6 p.m. So that's kind of nice. So we'll see. I think that might be what we're doing going forward. So I'm going to put a little poll in the Discord server to see what everybody thinks. But for now, that is it. Have a great night, everybody, or day, or whatever time it might be. And I'll see you in a couple days. Bye, everybody.